If you're familiar with my channel, you will know that I'm into Z80 computers and I like building kits. This was one I bought last year from a lovely chap called Andy Toon, aka Fearsome Technology Limited. It's called the MicroBeast and the kit comes in this rather lovely embossed box. The box itself, as you will see later, also doubles as the computer's case. Right, so tag here for opening it, which is quite nice. Pop that up there. We have a lovely printed manual with some helpful warnings on the front. Stop before you go any further. To avoid damaging this kit, please take note of the following. So there's a useful guide there for somebody that's not done a lot of soldering before. And according to this, Andy reckons it'll take a couple of hours to build, which is fair enough. So some tips there. And if I open this up, it's got a rather large this. It's not in book form, it's like a poster. You've got a full list of instructions here, and let's just zoom in on this. A layout of components on the board and a parts list, grouped by bag, which is good. So let's just put that to one side a second. What else do we have here? A packing list, packed by Andy, 7th of May 2024, so that's roughly when I bought it, almost a year ago. It's been sat on my shelf for that long. We've got lots of bag components. So we've got capacitors and connectors there, more connectors, looks like a probably a resistor pack there, an LED resistors. What have we got in here? Lots of resistors, a couple of capacitors, lots of keys. That's going to be fun soldering all those in. And keycaps. Power. Another button, probably reset button. Another resistor. A bag of chips. These lovely LED displays. These are what attracted me to the kit in the first place. It's got like the, is it the microprocessor? With the LED display, so you could use this computer standalone, battery powered, with the LED display, and it's got the built-in keyboard that we're going to assemble later. It's just rather natty, isn't it? Those LEDs. Oh, sockets as well. That's good. Again, attention to detail. This lovely, looks like laser cut keyboard frame. I don't know what's in there. Looks like a battery of some description. These, I think, go over the LED displays. I like filters once you've done it. So let's just put those there for 1 second. Keycaps. They look self-adhesive. So let's just stick that over there. And I'll take these out so I don't crease them. You go there a second. We have, if I can get it out, the PCB. Just hold on a second. Right. There we go. Let's take this out. In fact, let's move this box out of the way, put the precious things in here so we don't lose anything. Let's do this properly. Just move these all out of the way for one moment. There we go. Put those to one side. Look at that bad boy. Let's leave that there. Right, we have positions for all the keys there. So it's got like a chiclet keyboard. Quite a few chip sockets to put on there, so there'll be a Z80. Presumably there's a PIO, RAM, ROM, so on and so forth. And whatever else on there, a load of discretes. It's got FTDI built in. That's handy. I2C. Very good. I think that at the top there, that's an RC 2014 compatible bus. I remember Andy talking about that now. And there's a backup battery goes on there. 3 to 5 volt centre positive. I don't know whether it can power it off the USB. I guess I'll have to read the manual for that. For those of you that are probably not as familiar with soldering as I am, you'd be pleased to know that the surface mount components, these fiddly chips down here, and there's a whole group of surface mount components over here, have already been pre-soldered, so you don't need to worry about that. Everything is through hole, so it should make things a lot easier. A lot easier. But there's 3 surface mount chips. 4, there's one over there as well, a tiny one. Yeah, that will make things a lot easier. Right, so let's have a look at the instructions and see what's involved in building this. Right, so I guess I'll start in the order that they're listed. I'll do the small components first. So, bag 1. I've got some soldering irons are warming up. Side cutters, are they ready? I've got a component former, which is handy for bending legs on resistors and stuff. So let's start on the easy one, R315, which goes up at the top here somewhere. There we go. Perfect. Perfect. Definitely going in the right one. 315. So just bend the lead slightly at the back. Let's start soldering. The bags seem to be organised in a way that the component values are not easy to get mixed up, which is good. Just tin my soldering iron. Where are we? There we go. Right, I feel like I'm making progress. 1 down, several to go. Let's just check the quality of the joints. Perfect. And snip. There we go. Put those there out of the way. There we go. Right. What's next? Diodes. D10, etc. Let's flip it over, find D10. Oh, D10's up in the corner there. Let's just double check that. D10's up in the corner. So again, a bit fiddly to get at. I think I can use my former on this. No, that's a bit narrower, that. I can't form it, I'll do it manually. So let's just bend them at 90 degrees manually like that. You've got the black stripe. In fact, let me just zoom in on here a second. Move those instructions out of the way. There we go. Can we see that? One side's got a black stripe. It's on the right. Okay, that corresponds to the white stripe on the board. There we go. So let's have a look. D10. Bend the lead. That's ready for soldering. Yeah, so that's D10. So let's get that soldered in then. So the black stripe is the polarity. If you imagine the schematic symbol for a diode, it's like a triangle with the point pointing towards a kind of a black line, and the current flows in the direction of the triangle, and it's blocked going over the way, indicated by the black line. Well, the stripe, that's the black line, isn't it? So let's have a look at this then. Let's solder it in. There we go. Sweet. I might speed forward through sections of this. Let's see how we go on. Y32. That sounds like a crystal to me, which will be this tiny little fella here. There we go. And then I'm just going to bend it like so, 90 degrees, and hopefully that should be enough. I'm going to get some blue tack and just hold that in place a second. Right. Blue tack's very handy for this kind of stuff. So I'm just going to tack you in place nice and straight there. And there's just about enough lead poking through the other side there to solder on. That's good. Just check it's still straight on the other side. Yeah, that'll do. It is in the right place, isn't it? Just double check. I32, yeah. Where was it again? Oh yeah, down there. I could really do with a finer soldering iron tip than this. Yeah, that'll do. There we go. I really thought that was going to be the fiddly bit. That's bob on that. Happy with that. Right, next. There's a curvature on the transistor there. These go in, they're polarised. So I'm going to follow, bend the lead slightly. Just so I can get it in the hole. It's definitely Q1, isn't it? Well, I've nearly finished the first bag. That wasn't too bad, was it? Just clean my soldering iron. That'll do. I thought this solder would be too thick for this, but to be honest, it's doing alright. It's a bit agricultural. I can live with that. let's crack on with the next bag. So the next bag is bag number 2. It's only got a handful of components in here. Let's see what we've got. Empty it out. Right. That's empty. So the next is the reset switch and the battery. So let's put the battery cell in first. Okay. Which way does that go then? It goes in that way. Starting to come together now. Now my advice, and Andy echoes this, is if you're soldering in anything with more than 2 pins, it's to do just diagonally opposite pins rather than soldering them all in, because if it's not level, you're going to be stuffed later. Also, blue tack always comes in handy just to hold things in place whilst you flip the board upside down to solder. So let's just do that now. Get some blue tack on there. Just there will do. Maybe I'll put it on both sides actually. Yeah. There we go. Just put that there and there. Just tack it in place. Yay. Because if you solder all of the pins and it's not level, you're stuffed. You have to unsolder it all and start again. Whereas if you just do top left and bottom right, you can flip the board over and level it up, tack it in place with just those 2 pins, and then you can solder the rest in. There you go, so that's top left and bottom right. Remove the blue tack. Let's see how level that's looking. This is kind of important, I suppose, because the negative side of the battery contacts on the base there on the circuit board. So you really want this as tight as possible. I think that is probably it. Nope, the little click there. Let's just check this one again. Ow! Ooh. Spicy. Hot and spicy. Yeah, that'll do. Let's get the rest soldered in then. No noise there, it's just me cleaning the tip of my soldering iron. Do it regularly. Probably do it more often than I need to. That's that. What's next? Switches aren't square, they're kind of rectangular. So it will only go in one way. Let's get that nice and flush again. It's starting to come together this now. That's the reset switch. Probably get to use that a lot. One. Come on, you can do it. 2. Again, make sure this is level. That's looking pretty good actually. I don't think that's going to get any more level than that. Right, solder the rest of that in. It's all about patience really, soldering. Take your time, enjoy it. That's good. Clicky clicky, that's good. What's next? power, and let's do the power. That's only going to go in one way, isn't it? It's going to go with the jack facing outwards. It really is quite a nice design board, this. Where's my blue tack gone? Tap this in a little bit as well. Losing my voice here, I do apologise. I need a drink. That's what I'll do in a second. I'll just pause the video after I've soldered this in. I'll get a drink. There we go. Cough come right. Where's that? Put plenty of solder on this because it's going to take a lot of. Well, I don't know if I'll use it actually. I think you can power it off the USB. But we'll put a lot of solder on it anyway, just on the safe side. There we go. Come on, you can do it. Flow, flow, my pretty flow. Got two more. Yeah, so the solder on these components are partly electrical, partly structural. Load bearing solder. That's good. That's nice and level, which is a good job because I've soldered it in now. And then we've finally just got this one more component of the bag to go, and that goes here. Pretty sure that goes here. Jumper 33. Starting to. There we go. Now these do require blue tack because they tend to fall out when you flip them over quite readily. This is going to look rather smart when it's done. Look rather smart. So again, I'm going to flip it over and just do top left and bottom right, level it up, and then solder the rest in. That. I think this is pretty level, to be honest. Oh. Yeah, try not to hold the pin you're soldering. Top tip. That's not going to get any leveler, I don't think. Let's get that soldered in there. Right, we're on packet number 3, and it looks like we have, move that out of the way, talking about the RC2014, the RC2014 compatible I/O there, an LED, 2 resistors there, a resistor network there, 2 capacitors and another capacitor and another female header. Right, let's get cracking on with this then. So what are the resistor values? They are, hang on a second, let me me just compare them. I think they're both the same according to the specs. So you notice on the LED, probably teaching grandmother to suck eggs here, you've got one leg that's longer than the other. I think the long leg is the anode and the short leg is the cathode. So the long leg is plus and the shorter leg is minus. So if I have a look on the board here, you've got a, that goes there, I assume, diode 61. You've got the flat edge on the left hand side, so the flat edge is the cathode and the cathode is the shorter lead, so I can just about feel the flat edge on this, I think. So it needs to go in this way, flat edge there. I might as well do this while I'm at it then. So the LED goes in that way. There's only one way to find out. I'm pretty sure I'm right there though. So let's just bend that, get that soldered in. There we go. Because LEDs, like their non-light emitting counterparts, will only light up if you pass the current the right way. Although I suspect if you pass enough current the wrong way, it'll probably still light up, just in a different kind of way. What's that? There. That will do. I assume that's in the right place. Can't be more than one LED, surely. I'll just put that in without thinking. That's nice and tight. That's good. Let's do that capacitor, which is capacitor 38. Oh, found it. Okay, sorry, I paused the video there, so it looked like I've come to an instant conclusion as to where this capacitor goes. It was a little bit confusing because capacitor 38 on the board is marked polarised. It's up here, but it's not an electrolytic polarised capacitor. So capacitor 38 goes in there. That was a bit of a hunt. Let's do the resistor network next. Okay, so as I suspected, it does matter which way you put these in. Let me just zoom in on this. So let's see if we can get close up. I don't know if you can see that, but there is a circle there on the left hand side of the component where the markings are. Okay, so that's pin 1. What we need to do is match that with the square there on the board. That's pin 1. So let us do that. Look at that there. That's not going to go through the holes, is it? Let's trim them off. There we go. So which was pin 1? That was pin 1. So pin 1 goes there. Okay. Bit of blue tack. Bit of blue for the lads. There we go. And what I will do here is I'll just solder one pin in. I think Andy's instructions recommend that anyway. And make sure it's nice and level before I do the rest. And where the dickens has that gone now? Oh, there it is. Can't see the wood for the trees. There we go. Oh yeah. Oh Oh yeah, look at that. Bob on. Bobby Dazzler. Right, let me sure I've got pin 1 in the right place. Yep. So let's do the rest of these then. Let's see what that looks like. Bob on. Just got those. Where did they go? Oh, there. We've just got some connectors to put on now. I'll do the little one first. Okay, actually I won't do the little one first. I'll do the big one first. J31. Because J36 fits flush with that and J35 fits flush with that. So I'm going to tap this one in place. I need a bit of blue tack, I think. And then I can attach the other two. I'm going to stay on. It was fun doing the backplane for the RC 2014. There were loads of these, must be about 8 off the top of my head. So I've got the RC 2014 Pro. It's a good idea, the bus though, because it exposes all the Z80 signals and a few others like the clock and the serial. So if you're debugging stuff, you just can poke a DuPont ribbon cable in there or whatever, and attach it to your breadboard. Okay, I think that's level. One way to find out. So I'm just let me stand up so I can do this in camera. Literally just pushing it flat against the board whilst no, there you go, that's bob on. It's not going to get any flatter than that. You can feel it if it's flat. You can feel if it's flat. So hopefully with a bit of luck I'll just look at that. There you go, bob on. So let's tap this one in place. Blue tack. Blue tack. It's the best invention ever. So I'll just solder this on with one. Oh. Or two even. Two for the price of one there. I bridged it and then unbridged it. I'm sure it's level. Good job. There we go. Yeah, that feels pretty level to me. And just this fella here then. That goes there. Don't know what that one's for. Don't recall having that on my RC 2014. Extra. Well, there's probably blue tack, you know, kind of like slight trace of blue tack all over your board. There you go. Once you build it. That is absolutely perfect. Cool. So we've now got connectors, battery. I think that's presumably for the real-time clock. Power. Starting to get there. Right, next, bag 4. Boing. This is the one with all the capacitors in it. So let's empty that out on here. And I'm not kidding about it being all of the capacitors. Crystal. Where does the crystal go? Y10. Y10. Okay, so that goes up here. Crystals are not polarised. You'll be pleased to hear. That goes in there. The heartbeat of the computer, 8 megahertz. It's quite fast, that. Spectrum ticks along about 3.5 megahertz. Then you got silly speeds like the Spectrum Next goes up to 28 megahertz. And that's all done using FPGAs and Voodoo. Doesn't feel like proper stuff to me sometimes. Running a very clever stuff though. I love my Spectrum Next. There we go. So we have a heartbeat. So a crystal's usually got support circuitry to make it oscillate. So there's a capacitors and resistors around it. They'll be tuned to make it oscillate because it'll either work or it won't work. So I decided to just crack on and finish soldering up bags 4 and 5 that contain most of the discrete components, and that's more or less finished now. I have all of the components on board apart from a row of headers here for the I2C and a crystal that goes there, and I'll solder those on after I've just finished this video. So the next step, this video's longer than I normally shoot, so I'm going to split it into 4. The next video I'll be populating the ICs, the row of LEDs that go here, and the buttons of the keyboard. And then in the third video I'll test it, make sure it works, and then in the 4th video I'll finish off the aesthetics, completing the keyboard assembly, fitting the keycaps, installing it in the box, and then running through some of the applications. So yep, that's it for today. I hope you've enjoyed this video. Like I said, it's a little bit longer than I normally do. I've tried to cut it down as much as possible so there are bits missing. And I'll see you in the next one.